Okay, we're going to try and reconcile triangles with resolving vectors down a plane. So let's go back to the old right-hand triangle and just recall which parts are which. So if this is our plane, this is like a ruler that we've set up running down the bench, and we've chopped it up with some blocks over here. This is the angle that the plane is set at compared to horizontal, or compared to the bench or level surface. So this is the angle theta that we're talking about. So let's just remember that if this is theta here, this is the opposite side, this is the adjacent side, and this is the hypotenuse. So if we have a force directed down the plane, then the hypotenuse is the force. So we can figure out the components of the force that would be acting in this direction and also in this direction, because we know the relationships, the trigonomic relationships of an angle in a right-hand triangle. So over here on the opposite side, we're going to have the idea that this is the opposite side. So let's just call this op. And this is the adjacent side. And now let's look at some of our relationships. So sine theta is going to equal opposite over hypotenuse, F. Cos theta is going to equal adjacent over hypotenuse, or F. So now we've got some great relationships happening here. We can use these to plug them back into the triangle. So rather than calling this op for opposite, let's get rid of u and let's get rid of u. Okay, we can rearrange this side. Opposite would equal F sine theta. Okay, all I've done here is got the opposite by itself by timesing everything by F. And similarly, we can do that for the adjacent side, and we can, rather than calling it adjacent, we can call it F cos theta. Now the same is true if we consider, let's do the same for F being over here and figure out what this component is here. Okay, let's apply what we know about triangles now to a new situation. Let's think about everything that we've just done as a right angle triangle with an object moving down the slope. And we have to think about the forces that are acting on this object. So we have the force due to gravity. We have a force that's going to be applied parallel to the way that the object is moving, or basically in the same direction that the object is sliding down the slope. And we also have like a reaction pair, normal reaction pair of the box on the incline, or say it's a ruler and a marble, and the marble on the ruler, and that's always acting up at 90 degrees to the surface. So we can put that one up here, and so this is going to be our right angled triangle here. So we can notice some similarities. We've got two right angled triangles. This is theta, the angle that the slope makes with the horizontal ground, and this will be theta in here of our new triangle, which is a similar triangle. So let's label the forces. This is the force due to gravity. This is the force normal. We call that, we can use capital N for normal force. And this is the force of the object's acceleration. Let's call it FA. It's not a very good A. And basically we can apply the same rules that we just learnt about how to label the triangle to this new red triangle. So if we think about this new red triangle, and I'll try and draw it over here. If this is FG, and this is theta here, then this one here, this FA that we're trying to figure out, let's write it in black, well, it equals FG sine theta, just like in our last one. And that's pretty helpful because this exact relationship, the force due to gravity times sine of the angle that the incline is making, that's going to give us the force, and then if we know the mass, the acceleration of the object moving down the slope. And that's that's the key thing that we really want to know. Sometimes we want to figure out what this normal reaction force is to think about things like friction. So we could say the normal reaction force is Fg cos theta because it's adjacent. And so either way, you can use that principle of trigonometry, let's get rid of me, to analyse the forces on an object moving down a slope.